Hello, good day everyone. You are welcome back to another interesting question. We are asked to calculate the area of this blue portion. Let's assume its area to be S. So we are to calculate the value of S. From here, we are given that two of the shapes here, one is a semicircle and the other is a quadrant. Obviously, there is a semicircle and there is a quadrant. We have the length of this red line to be 245 meters. We can see this line segment and this are congruent. So how can we solve this? How can we calculate the area of this portion S? From what we have here, if we subtract the area of this triangle and this from the area of the quadrant, we'll be left with the area of S. So if we assume the area of this to be T and label this point O, we can say S equal to area of quadrant minus T minus area of triangle OPQ. Now we need the value of the area of the quadrant, T, and area of triangle OPQ. If we focus on this semicircle, we know definitely this is its diameter, and diameter is made up of two radii. So since this is the midpoint of the diameter, definitely this segment and this segment are radii. Radius always start from the center of the supposed circle. So this O here is the center. We can see this line here also starts from the center to this one on the arc. So it is also a radius. Now look at this T. Since it is enclosed by two radii and an arc, it is a sector. So T equal to area of sector. The formula for calculating the area of sector is theta over 360 pi r squared. Theta is the central angle of the sector, which is this here. R is the radius. We already labeled this radius R. So T equal to theta over 360 pi r squared. We substitute it here. Now S equal to area of quadrant minus theta over 360 pi r squared minus area of triangle OPQ. For area of this quadrant now, a quadrant is 1/4 of a circle. So area of quadrant equal to 1/4 area of a circle. Area of circle is pi times the square of the radius. So area of quadrant equal to 1/4 times pi times radius squared. If you look at this quadrant, we know this and this are its radii, because a quadrant is also a sector, which is 1/4 a circle. So since the length of this side is sum of this R and this R, that means radius equal to R plus R, which is 2R. We come here, replace radius with 2R. 2R all squared is 2R times 2R, which is 4R squared. This 1/4 times this 4 is 1. So area of quadrant equal to pi r squared. We replace this area of quadrant with pi r squared. So S equal to pi r squared minus theta over 360 pi r squared minus area of triangle OPQ. Since this side and this side are radii of the quadrant, the length of this side will also be R plus R, which is 2R. If you look at the angle, it is an angle of a quadrant, and the angle of a quadrant we know is a right angle. Now if you focus on this triangle, because of this angle here, it is a right angle triangle. The formula for calculating the area of a triangle is 1/2 base times height. When it comes to a right angle triangle, the perpendicular sides are the base and the heights. So if we take this as a base, this must be the height. So B equal to R and H equal to 2R. Substitute it here. Now area of triangle OPQ equal to 1/2 times R times 2R. 1/2 times R is 1/2R. Multiplied by 2R is R squared. So area of triangle OPQ equal to R squared. Replace this area of triangle OPQ with R squared. From pi R squared minus theta over 360 pi R squared minus R squared. R squared is common. We factor it out. So it is R squared into bracket pi minus theta pi all over 360 minus 1. Pi has an approximate value 3.14. This 3.14 minus this one is 2.14. Theta times 3.14 is 3.14 theta. So S equal to R squared into bracket 2.14 minus 3.14 theta over 360. Now what are the values of radius and theta? We don't know. But if you come to this triangle, since this side and this side have the same length R, that means it is an isosceles triangle. The base angles of an isosceles triangle are congruent. So this angle and this are congruent. Let's assume their sizes to be x. Now look at this angle theta. It is an exterior angle of this triangle. We know the rule that the exterior angle of a triangle is equal to sum of the two opposite interior angles. So it is equal to the sum of this x and this. Therefore, theta equal to x plus x, which is 2x. Substitute here. Now still on this triangle, based on the rule that the summation of angles in a triangle is 180 degrees. Since this is x and this is x, this must be 180 degrees minus 2x. Now if you use the sine rule on the triangle, this side divided by the sine ratio of this angle must be equal to this side divided by the sine ratio of this angle facing it. So R over sine x equal to 2 root 145 over sine 180 minus 2x. From trigonometry, we know the sine ratio of 180 degrees minus any angle is equal to the sine ratio of that angle. So this sine ratio of 180 degrees minus 2x will be equal to sine 2x. So R over sine x equal to 2 root 145 over sine 2x. Multiply both sides by sine x. Here sine x cancels sine x, while here 2 root 145 over sine 2x multiplied by sine x is 2 sine x root 145 all over sine 2x. So R equal to sine x root 145 all over sine 2x. Now what is x? We don't know. But if you look at this right angle triangle, we know since this is 180 degrees minus 2x, this must be 90 degrees minus into bracket 180 degrees minus 2x. Minus into bracket 180 degrees minus 2x is minus 180 degrees plus 2x. 90 degrees minus 180 degrees is minus 90 degrees. So it is minus 90 degrees plus 2x. Minus 90 degrees plus 2x is minus into bracket 90 degrees minus 2x. Now if you use a SOHCAHTOA, taking this angle as C, there is the opposite and there is the adjacent. From here, tan C equal to opposite over adjacent. C is minus into bracket 90 degrees minus 2x. Opposite is R and adjacent is 2R. Here R cancels R. So tan minus 90 degrees minus 2x equal to 1/2. From this, minus into bracket 90 degrees minus 2x equal to tan inverse of 1/2. which is 26.57, minus into bracket 90 degrees minus 2x is minus 90 degrees plus 2x. Take minus 90 degrees to the left, so 2x equal to 26.57 degrees plus 90 degrees. 26.57 degrees plus 90 degrees is 116.57 degrees. Come here, replace this 2x with 116.57 degrees. Also, here sine 2x, substitute the value of 2x, so it is sine 116.57 degrees. Come back here, 2x equal to 116.57 degrees. Divide both sides by 2. Here 2 cancels 2, while here 116.57 degrees divided by 2 is 58.285. Substitute it here. Now r equal to 2 sine 58.285 multiplied by root 145 all over sine 116.57 degrees, which if you press your calculator is 22.91. Substitute it here. Now s equal to 22.91 all squared into bracket 2.14 minus 3.14 multiplied by 116.57 all over 360 degrees. If you press this in your calculator, you'll get s equal to 589.56. That is, the area of this blue portion which we are asked to calculate is 589.56 meters squared. Thank you for watching. Please subscribe, like, share and comment. Thank you.